Okay, so we wrote a very short little loop here. It says, in this case, I'm just going from 1 to 10. For I, or start at 5, stay less than 10. Mathematica has an awesome function called integer exponent that says if I take the factorial, or take any number, I can find how many primes, or how many amounts of this number divide into it. So, a is the number of times 5 divides into n factorial, which is going to tell us the number of zeros.
Yep.
B is the number of times 5 divides into 2n factorial, which is going to tell us the number of zeros in 2n factorial. And then I have an if statement here. Right now it says if 1 equals 1, which means it's going to print all the time, but we'll modify that in a little bit.
Yep.
Okay, and so we ran it just for 5, 6, 7, 8, 9, and we found what we thought. The number of zeros in 5 factorial is 1, 6 factorial is 1, 7, 8, 9. And the number of zeros in 2n factorial, so 10, 12, 14.
Look, it's doubled.
15. So
tripled.
there it was doubled, and 8 and 9 are where it was tripled, and we found that, didn't we? Put an extra space in there just to make it a little easier to read. Okay, but now let's look at when is it exactly double, like what you guys were thinking it might be. If A, so B equals 2 times A. Okay, so we should just get 5 and 6 first. Oh, sorry, 5, 6, and 7. But now let's find some other ones. Let's go up to 100.
The doubles.
Ooh,
There's a lot.
there were a lot of doubles.
So 5, 6, 7, 10, 11, 12, 25. I mean, we can look at the triples and
26,
see.
27, 30, 31, 32,
Okay.
35.
Yeah, we sure can look at the triples. There's 3 times.
There's a big gap. 37 to 50.
Whoa.
It's like a big gap.
Yeah, I wonder what was going on there. The triples, there's only seems to be 4 of them.
In 100, wow.
Up
You
to
could
the
go
first
to
one.
1,000.
We could go up to 1,000. It starts being a little slower than you might normally think, because the factorials are hard calculations. But you can see there's only those same 4 up to 1,000. But up to 1,000, let's see if there were lots of doubles. Oh
Whoa.
yeah,
Whoa.
tons of them. Okay, wow. Like the last one was 937.
Zeros, 232.
I'm not sure if that's
464
Yeah.
zeros.
Oh, sorry. I might not have scrolled down far enough. But anyway, so we found lots of doubles. So if we're not getting very many triples and we're getting lots of doubles, what's the next thing that could be happening? It's not exactly equal to twice n, or to the number of zeros isn't doubling.
Well, it could be between 2 and 3.
Okay. So what's one thing we could look at? What's that?
Or if B is greater than 2A but less than 3A.
Ah, okay. Well, let's just pick a number that would be greater than 2a, where we might see some zeros.
What do you mean greater? Like,
What's a specific
6?
number that could be greater than twice?
6.
Well, 6, if a is 10,
I'm not sure what
2A.
you mean.
what's an expression that we could write down? So right now we're saying b equals 2a. And we found that there weren't many where b equals 3a.
Yeah.
But what's an expression we could write down that we would think would be bigger than 2a, but probably less than 3a?
How about B is bigger than or equal to 2A?
Okay, we could start there. How about we'll just say bigger than 2a?
Okay.
Okay, so here we found a couple. 1 went to 3, 1 went to 3, 2 went to 6, 2 went to 6, 3 went to 7, 3 went to 7, 3 went to 8, 4 went to 9, 6 went to 13. So how does that relate? How does 3 relate to twice 1?
Well, it's
How does
one more.
7 relate to twice 3?
So it's one more than twice 3.
So we could be looking for ones where b equals 2a
Plus 1.
plus 1, which is pretty close to 2a. So we find a lot. And what could be the next thing we look for?
How about plus 2?
2a plus 2.
Still seems to be a lot.
Okay. So the first one we found was 13, when at 2a plus 2. What's special about 13 when you double it?
Well, it's 20. It's It's 26.
Okay, so why did we get an extra gap in the?
Well, because of the 25.
25.
Okay, let's see what happens when we go to 2a plus 3. The first one's 63.
And so 60.
Well, you have the
60?
you have the 25 and the 50 in there. In 63.
Well, what 63 is the number we're doubling.
So you're gonna
So,
you
si-
125.
63, so 126.
Okay.
Yeah.
So,
That's one more than 125, which
Yeah.
adds 3 zeros.
aha. So what do you
that's-
think is gonna what do you think is gonna be the critical number for the first time we see 2 times the number plus 4 more zeros?
Probably 625.
Okay. Well, not 625, but we got 313.
313 is.
That's
600
one more.
626.
Yeah, it's one more than 625 when you double it.
Okay. And how about plus 5?
So 3,126.
None?
Oh, because I'm stopping at 1,000.
Yeah.
Let's go to 2,000. Okay. 1,563.
Yeah, so that would be 3,126 when you double it.
Okay. So we weren't ever seeing 3 times as many ever again, but we were seeing 2a plus 1, 2a plus 2, 2a plus 3, 2a plus 4, 2a plus 5, and they were starting to really spread out.
Wow.
Because the first time we saw 5 extra zeros was at 3125, which is 5 to the
It's 5 to the
Fifth.
5th, yeah.
5 to the 5th. Okay.
Wow.
So are there infinitely many that have 3 times?
No. Only 4.
Only 4.
Cool.
Cool.